This is my second video explaining physics. This time I'm gonna explain how to find the force of tension. So here's the problem. We have two strings here tied up to some sort of 18 kilograms box or whatever, or object. For each string or rope there are different angles. For this one there's a 45-degree angle, and for this one there's a 20-degree angle. Using this we can build triangles, this one and this one. This one here is the force of tension for rope 1, and this is the rope 2. Okay, so after that we use SOHCAHTOA and we find the X and Y directions for each of the triangles. This one is for the case of the 20-degree angle, so force of tension for rope 2. Okay, after that we find all the variables. In this case it was the Y direction for the T2 rope is 0.342 T2, and for the X direction it would be negative 0.93 T2. Why would it be a negative? Well, because from each triangle we can make a second different triangle, which is well actually the same, and we'll build the planar which states which is negative and which is positive. In this case, this will be the planar, this here. Okay, so if you go from here to here, this would be the X direction of the second rope. It would be a negative. And for the case of the Y direction, well, it will be positive. Here you also have to do the X and Y. Well, find the X and Y directions of the other triangle, and here are the values. For the value of Y, it would be 0.707 positive. Well, again, because here's the planar and it starts from here to here, making it a positive. And the X direction will also be a positive because it starts from here to here, making it, well, a positive. And the values are both the same for sine 45 and cosine 45. It will be 0.707 T1 because of the value. After that, you have to find the net force of each triangle, of each direction. I mean, for the case of X, here are the values of X: negative 0.3, which is here, 0.707, and you simply sum it up. Well, in this case you will have to subtract them because one of them is negative. After that, you have to set the net force to 0 and pass one of the values to the other side, making it 0.93 T2 equal to 0.707 T1. After that, you will have the value of T1, which will make it 1.3281 T2 after dividing 0.93 by 0.707. After this, you have to do the net force of the Y direction. You do the same process. The different thing in this case, it would be that you have to add the force of the third rope, which is this one, and you determine this force by using the formula of force. In this case, the formula the force of gravity would be equal to mass times 9.8. In this case, the mass would be the mass of the box, which is 18 kilograms, and multiplied by 9.8, which is the acceleration of gravity downwards, and make it equal to, and this would be equal to 176.4. Then after that, you set the net force. You get it by subtracting Ft3 minus well, the force of gravity, and then we make the net force equal to 0 and pass one of the variables to the left side. In this case, it would be Ft3, and this would stay negative 176.4. Well, and here's the value here. So you add both of the y directions and subtract the negative direction, which would be 176.4. And now that we have the T1 value, which in this case is 1.3281, no, I mean 1.3289. And after that, just simply replace the variable, which is this. Okay, after that you multiply this by this and have this answer, and that set the net force of y equal to 0 and pass one of the variables. In this case, we would pass this variable here and add these two, which would give us an answer of 342.93 T2. After that, you divide this by this to have T2 by itself and have the value of T2. So the value of T2 would be 0.514. After that, now that we have the value of T2, we simply multiply we just simply replace the values. In this case, 1.3289 times T2, which is 0.514, 0.514, and then we just multiply it and we get this, which will be the force of T1. So T1 is equal to this, T2 is equal to this, and T3 would be equal to this.